So good afternoon, everybody. My voice is audible to all of you, right? So now, today, so last day, in the last three sessions, we studied how to create databases, tables, and how to modify the structure of the table, and all we studied in the last three sessions, step by step in a simple manner. Okay, we never went into complex things, right? So here, just please check our table, last session table. So our database is online mart. So to make it active, use database name online mart. Just execute that. Right. Now, is there any tables in the online mart? There is no, because last day we executed the drop table command, right? So we want to create the table once again. Now let us create a table first. Create table, table name, product, opening parenthesis, product ID, integer, product name, varchar of say some 30, quantity, say varchar of say some 10, and price integer, right? So here here I'm trying to create a product table without any constraints, without any major specifications. Just it is a simple table with just 4 columns and their data types also. Even I'm not checking whether they are appropriate or not, because last day I told you, you should know what is the importance of constraints. Okay, what is meant by normalization? What is meant by data consistency? What is meant by data validation? I mean that valid data. What is meant by bad data? Okay, so to go through to study about that concept, okay, I am using this table. Now execute this table command. Successfully executed. Use the command show table. Right, table product is there. Now describe the table. Right. See here, product ID, product name, quantity, and price. 4 columns in that table. Okay, just their data types and their sizes. That's all. Okay. Now, if you work with this table, what type of data we can store? Just check it. Okay. Now, how to insert the first row? Now, let us prepare some data. Based on this design, I need product ID. So, product ID, just assume 101. The product name. Okay. Tur dal. Okay. And its quantity, say 1 kg. Its cost is say some 120 rupees, just assume. Okay. Right. Now, 102. 1 kg. Okay, maybe some 80 rupees. In such a way, just prepare some data. Right. Now, this first two is okay. how to insert this data in this table. For that, we need a insert command. Insert, okay, into product values. What are the values? Say 101, tur dal, say 1 case, and it is around 120 rupees. Now I want to execute this command. One row inserted. See, this command is I'm inserting all the rows. Command I used is insert space into space product table name values. These 4 values. For product ID 101. Okay, it is integer. So direct value, comma. Second one is a string, so that the string value should be enclosed by single quotes. Okay, single quotes, so that it is treated as a string, comma. It means each value should be separated by comma. Next, again the sorry, quantity is again a string, so that that value should be enclosed by single quotes, comma. Next, the value, the price 120. You insert it. Now this data seems to be valid, right? 101 tur dal 1 kg 120. It is okay, right? Now insert the second one also. Right. Copy this line, paste it here. This is second row. I inserted second row also. Okay. Now select the data, whether it is inserted in the table or not. So select all the data, means star. Star means all the data. From which table? Some product table. Now execute this. Now you got this data. See, 101. Okay. See, column name, product ID, product name, quantity, price. Under each column, the values. Now this data, when you are doing a project, this data should be a valid data. Okay, in the real time, how many products you insert in this product table? Thousands of products, thousands, even sometimes lakhs also, even sometimes. But anyway, if you pick any supermarket, or if you pick any shop, okay, some kirana shop, any shop, at least 400 to 500 products will be there, right? At least 4 to 5 products. Sorry, 400 to 500 products at least. It means around hundreds of products data, right? So hundreds of products IDs, product names, quantity, and price. This data should be valid always. Okay, your database design should assure about validity of the data. In such a way, you need to write the create table command. Everyone writes create table command. Everyone creates the tables, but you need to create a table, okay, which allows only valid data. That is one point. Second point, if anyone tries to insert the invalid data, it should reject. That is the important point. Okay. See, this is the select command. Okay. See, I will revise all these commands with the proper syntaxes later. But here, why we are concentrating on the basic commands step by step means to create a perfect table or tables. Okay. we need some sort of knowledge is required. What is that? How to avoid the bad data? We should know, right? And why multiple tables are required for your project? Why a single table is not enough? Okay. Yeah. See, to store different types of data, we need multiple tables. Okay, that is a general answer, but that is not the exact answer. Okay. See, to improve the performance of a database, what type of performance? See, when I want to insert the data, when I want to delete the data, when I want to update the data, or when I want to select the data, these operations should be happened in an effective manner at a maximum of at a every query need to be executed with the minimum time, in the less time, within seconds the query need to be executed under whenever the data is in terms of thousands of records. Okay, whenever the table is with few records, it is okay, but whenever see, I will tell you about the truncate command. Okay, right. See, today time is very less, so that's why we are going to concentrate on this one. Please wait. Truncate command, drop command, delete, all everything. Okay, data deletion, schema deletion. Okay, everything we'll see one by one. Now, first here, how to create a perfect table. That is very, very important. Okay, tables, that is very important. Now see, first try to insert into product values. Already I have one product, 101 and 102. Okay, now 103, it is okay, but 101 now I want to insert this row. 101 peanuts, 500 grams, 60. Let us see. Insert into product values, 101 peanuts, 500 grams, say some 60. If this query is executed, see what happens. Query is executed successfully. Now select the data, select star from product. See, it is successfully accepted. 101 peanuts, 101 tur dal. That is the first drawback. Okay. See, whenever the customer selected 101 product, okay, it searches for 101 product in the database. Okay, whenever in the billing system, whenever a product is added by using its ID 101, what happens? It searches for a product with whose ID is equal to 101. It finds two 101s, I mean more than one, right? So which product need to be selected? That is the main drawback. User selected, user purchased the tur dal or peanuts. Okay, this is ambiguity. So ambiguity should be avoided, okay, while the data processing is going on. Whenever the query is executing, okay, you should avoid the ambiguity. So it means, see, successful functionality is dependent on successful design. You got the point? Why that ambiguity is raised at the time of project execution, at the time of application programming execution? Okay, because the design accepted product ID duplication. Product ID duplication is accepted by the design. So when the design is failed, automatically it leads to the failure of application. This is the importance of design. Remember that. Don't think that design is a normal create table command. That's why I today, because of the last 2 days, I am trying to explore about this. But first of all, give a brief introduction to the tables and commands, creation commands and all. So now we are concentrating on this. So this is the first drawback. Simple. See, let us do that. Now, as the billing system searches for product ID 101, so select star from product where the product ID equal to 101. Now execute this. As a response to this query, you got two products, more than one product. Okay, this is invalid data. You are expecting only one product, but we got more than one. It may be 2 or 3 or 4. It is the main drawback, right? With this product ID, there should be only one product, right? Next after that, try one more insert record. Insert into product values of now I prepared one more query. Insert into product values. In the place of product ID, I am providing null. And green peanuts, 100 grams, 20 rupees. Okay. Now execute this query. It accepted. So select the product data. Please observe here. In the product ID column, 101 is repeated 2 times, and there is a product named green peanuts without product ID. Now, if the customer or our application, not the customer, our application wants to select green peanuts, how it selects? By using green peanuts. There is no product ID, only the name is there, right? Now, okay, just assume. I want to insert one more query. Execute this. Right. So I inserted one more product with the name, so with the ID 104, green peanuts, 100 grams, 20 rupees. Now select the data, select start from product. Right. Now, as we discussed in the last few minutes ago, see, there is no product ID to get the green peanuts. Now, to select the green peanuts, select star from product where product name is equal to green peanuts. Now, if you execute this one, it displays two products. Okay, with the name green peanuts, there are two products are there. Among these two, I mean more than one is there. Among these two, which one need to be selected for our processing? Okay, two products are there. So the name is not useful to select a product. See, what is your requirement? When I selected one product data should come. When I selected one product, okay, whatever may be the mechanism you follows, that mechanism should give an assurance that it always results only one value. Such a way you need to design. Such mechanism you need to follow. That is the thing. But here you are getting, when you used, see this, when you used ID, you got more than one. When you use the product name, you got more than one. Right, fine. Next, insert one more row. Now execute this insert command. Yeah, syntax error for values. VALUs. Now execute that. Yes, one row inserted. Insert into product values 105, 5 gram, 500 grams, minus 90. Now select star from product. Now there is a product 105 whose name is equal to 5 gram, 500 grams. It is available at the rate of minus 90 rupees. So minus 90 is invalid data for that column, for that product. Next, insert one more row. Insert into product values of 106. See this. In the place of name and quantity, I entered null. See, the query is executed. In the place of, see, product ID 106. There is no product name and there is no quantity. Only price is there, 99 rupees. Now execute show products. Sorry. Select star from products. Product. So 106, the product name is null and the quantity is null, but its price is 99. So if you see this data totally, see this. It is totally inconsistent data, right? And bad data. It is invalid data, duplicated data, right? See, 101 is duplicated, and a product is without product ID. A product is without product name. A product is with invalid price data. A product is with invalid quantity, right? So whenever your table is with this type of data, okay, the output, the output by using this data also becomes invalid, right, Ram? That is. So this is about a single data. Okay, I mean that one table data. But multiple tables, generally we are using multiple tables, right? So here, what is the need of multiple tables? Okay, so if we use a single table to store all the data, it is very convenient for us because everything is inside the one table. Why multiple tables are required? That is one important point. We need to discuss one by one. So here, table creation is not just, it is not a big thing, but creating a table with with proper schema or with proper structure, which allows always only valid data. Remember, which never allows invalid data. In such a way, you need to design. Okay, to design that, two things are required. One is what is meant by valid data and what is meant by invalid data. You should know first, right? Next, how to design such type of schema. Whenever you are creating a table, okay, how to design such type of structure which accepts only the valid data, and which rejects the invalid data. That is an important point. So here, see, for that purpose, see this here. While you are working with a database, your database may contain duplicate data. Your database may contain bad data. Your database may contain redundant data. What is meant by redundant data? Okay, large scale of duplicate data. Remember that, large scale of duplicate data. Okay, and data integrity. What is this data integrity? Okay, means, see, integrity means here, see, this product ID belongs to a particular category. Okay, without category, you are not allowed to create this product, because first you need to divide the products into categories, right? Now, for example, we'll go with one school example. See. Now here, one table is there, which stores student marks. And there is another table. Which stores student admissions. Okay. This is about the student admissions, and this is about student marks. Now there is a student whose ID is equal to 101, and the student name is X and joined in a class, say some sixth class in the section A. Okay, in the section A. Now I started making entry of marks here in the marks table. Let us see marks of say, for example, in the first unit, okay, say for example, max marks, say some 85, physics marks, say some 45, like that. In such a way, you are making an entry about the physics marks, chemistry, in such a way. Right. Now, these marks belongs to which student? See, first unit 85, 45, 90, 78. These marks belongs to which student? Say, see, to Mr. X. Okay, to the student named X. But how to identify? See here, just you have written the marks. But these marks belongs to which student? We don't know. So to identify that, the student ID of this column, sorry, student ID from the student table, here I mapped it. So these marks belongs to a student whose ID is equal to 2001. Okay. So that is the main benefit. Here you don't need to think any technical aspect. Okay. No primary key, foreign key concept. Just think just as like a user. See, here I have written some marks. This marks belongs to which student? Whose ID? A student whose ID is equal to 201. Right. Now, I entered one more student marks here. Say some first unit. I entered. Right. Now here you entered marks for first student. This marks you entered for which student? Say whose student ID is equal to 202, 2002. Okay. You entered 2002 student marks in the student marks table. But 2002 for the student 2002, the admission entry is not yet happened. See, first the student entry should be made in the admission table. Once admission is happened, then only entry in the marks. That is the sequence. So without entry in the admission, okay, how you can enter the marks? So first you should enter that data in the admission table. Now here, when you are making an entry in the marks table for a particular student, your design should check this student data is entered in the parent table or not, or in the primary table or not. Because without giving an admission, see, normally on paper you have given the admission, but in the software it should be entered. Okay, so your design should check for each student. Okay, for each student in the marks table, entry should be made in the first student admission table. You need to check that. So this is integrity. If this is not there, what happens? This 2002, see for this student 2002 first unit marks are there here. Now I want student data of 2002. How to get 2002 details are there here? No, that is. So this is the main. This is the connectivity. Okay, see the data is related, but why this data is related into two tables? Admission record repeats only one time, right? Here see. 2003, in the section A. This is only one time. This record is only one time. But this 2001 student, okay, means X, writes different exams. First unit, second unit, third unit, fourth unit, half-yearly, quarterly. So this 2001 number repeats how many times here? 2001 second unit. Okay, 2001 say third unit, 2001 say fourth unit, right? Next 2001 quarterly. Okay, see 2001 half year. In such a way, in the student marks table, the 2001 is repeated how many times? N number of times. So the relation between the student and student marks table is, see here it is for one record. Here there may be chance for 0 records or 1 record or n number of records. See here 2003 student is there. Student 3 for 2003 student, okay, no marks are entered. Yes, it is valid. Okay, because the student 3 not written any exam, just assume. Then for student 2003, 0 records. Suppose for 2003 student, one first unit is written, okay, then only one record. 2003 completed, first unit, second unit, third unit, then more than one record. So the relation between the student and student marks is 1 to 0, 1 to 1 or 1 to any. I mean that any number of records, right? That is. So here validation should be conducted. That is important. Suppose if I try to insert, okay, say some 2005 record here, it should be rejected because for 2005 there is entry is not made in the parent table, right? This is so. This is integrity. Clear? Integrity maintenance. This is called integrity. So why the data gets duplicated here? Why the database gets why the table contains invalid data? Because see, these are the mistakes. No primary key and candidate keys. Whenever a table is without primary keys and candidate keys, then duplicate data, there is a chance for duplication data. So if you want to avoid duplicate data, you need to implement primary keys and candidate keys so that you can avoid duplicate data. Next, multiple values in a single column. This is another concept. Okay, these are called atomic values. So here, multiple values in a single column. What is this? Let us see. Now there is a product 101. Okay. The product name is Turda. Up to here it is okay. Product ID is 101. Turdal is okay. Now the Turdal is available in the supermarket in 5 kgs. In 5 kgs, 1 kg, and 500 grams. Okay, and Their prices are, say, some 480, 120, 60. Just assume. Now I stored this data in this way. In each cell, okay, see, this is product ID, PID, and this is product name. The product name, P name, just assume. And what are these? Are quantities, right? And these are prices. Now, under quantity, 3 values are there. Under price, 3 values are there. Now I want to change the 5 kgs packet as a 380. Okay, 5 kgs packet as a 380, not the remaining things. Remaining 1 kg is 120 only, 500 grams is 60 only. Now I want to update. Now I want to change this 480 as a 380. How to write a query? That is the main problem. Suppose if the query is like this: update product set price equal to 380. Whose product? Where PID equal to 101. This is my query, right? So first search for a product ID whose ID equal to 101. Yes, this is the row. In this row. Okay. Now set price equal to 380. Set the value of price column is equal to 380. Price. Now immediately what happens? These 3 values are replaced with 380. Right? So one value replaced the 3 values. So it leads to data inconsistency. And whenever a column is with multiple values, you are unable to perform the updations and deletions successfully. Here I want to update just 480 package, 5 kgs pack only. Okay. So the remaining to be, I want them as same. But as the queries works on columns and its values as a single unit, okay, it treats the value of a column as a single unit. So that what happened? See, the query treated the 3 values as 1 value and it replaced that entire 3 values with 1 single value. That is. So multiple values in a single column is again a big problem for us. So next, the difference between duplicate and redundancy. Duplicate means just 1 value is repeated. Redundancy means the same set of data is occurred again and again and again. Okay, that is. Next, the 4th point is a repeating groups problem. Repeating groups means this one. A single column containing group of values, right? Now these groups are repeated again and again and again because, see, if you see the second product, 1 or 2, here 5 kgs, 10 kgs, 500 grams is there. But for chana dal, only 2 types of quantities are there. Only 2 types of quantities. Then say it is only 1 kg and 500 grams. Right. Now here the prices are, say for example, 120 and it is 60. Right. Now go for the third record. One or three. $100 grams. It is 20 rupees. Okay. Now go for fourth product. See how the apples are available. It is available in 3 packets. So one single apple, next 5, and 12. So one single apple, 6 apples and 12 apples. Now it is 10 rupees and 60 rupees and 120 rupees. Right, see? Here what happened? Please observe. There is no consistency here. In this column, single value. Here in this column, okay, I mean in this row, okay, in the price column, in the first row, 380, one single. Here 2 values, it is 1 value, and it is 3 values. Right. So that is the main one more problem. See that. Repeating groups problem resolved splitting the table into 2 tables. That is creating a new table with the repeating columns. So how to solve this problem? Split the table into 2 tables. Split the table into 2 tables. That is creating a new table with the repeating columns. So how to do that? Right. So in this price, okay, multiple values are there, right? So 5 kgs price, 1 kg price, 2 kgs price, or something in such a way. Then whatever the values repeat grouped, okay, I mean this, make them as separate. So how? Product ID is 101. What are the possible quantities? Okay, you need to create in an abstractive way. I mean that, see, 5 kgs, 1 kg, 500 grams, in such a way. Just make. See the product ID and quantity and price. Okay, so now the product ID 101, 101, sorry, 104, right? 104, and for 104 product, okay, single pack, okay, the price is 10. Now 104 again, 6 pack, it is 60 rupees. Next 104, 12 pack, it is a 120. Right. Next, take the peanuts, 103, 100 grams, it is 20 rupees. Next 102, 1 case, it is 120. Again 102, 500 grams, make it as 60. In such a way for 101 also. 101, 5 kgs, say some 480. Again 101, 1 kg, again 101, 500 grams, 500 grams, which is 60. And remove that's it. Now you need to form the relation between these two. Right? So enter the product here, enter the product price, quantity and price details in this. So make it as a new table. This is a product price details. That's all. This is only product table. So the product table contains product ID and product name, and product price details contains quantity and price. So for a product, there is a possibility for one or more price detail records, right, Ram? So in such a way, you need to split the tables, right? Now whenever you try to update, okay, now I want to update the 1 kg data, 1 kg price into, say for example 102, 1 kg, 120, right? See here you need to update the data by using a proper keys. What are they? 102, 1 kg, that is only one time, right? And whereas 102, 500 grams, that is only one, right? So how to write? Update product price details, set price equal to some new value, where product ID equal to 102 and quantity equal to the relevant quantity, right? In such a way you need to write. So it is a theoretical session, remember that. Okay, so when we create primary key, all columns with atomic values and no repeating groups, then it is called first normal form. Okay, so what is the rule for first normal form? Simple. Whenever a table with each in a table, each cell with single value, and there is no repeating of groups, then such design is called as a first normal form. First normal form, remember that, first normal form. Whenever the database is in first normal form, means in that database design, all the tables and their columns are with single values, atomic values, and there is no group of values. There is no group of values in a single cell, remember that. Then it is called first normal form. Okay, now next non-key columns are partially dependent on primary keys. It means that The table contains multiple entities. Non-key columns are partially dependent on primary keys. What is this dependency actually? See, to make our table more stable and more accurate and more performance oriented, one blind rule is there. That is, every table should be with only one primary key. Okay, a table is not supposed to have more than one key. Okay, and see, these are some blind rules are there. Suppose if you are unable to understand logically in the learning stage, one simple blind rule is there. See, just like for our body, how many heads are there? Only one head. See, what is the benefit of having only one head? Because the brain gives instructions. So the brain is the head. The instructions, I mean that, see, the center area, the center controlling area is only one. So the entire body acts according to the instructions of only one central area from which the commands are generated, right? Now, if two central areas are there, what happens? The body gets confused. Which central area commands need to be followed, right? Which central command options to be followed, commands to be followed. Now here, there is a word here, see this, non-key columns are partially dependent, partially. See, it is a logical statement, okay? It is very simple actually, but due to that English, it becomes a little bit complex, but simple, partially dependent, okay? Non-key means, non-key columns means where duplication of data occurs, in which column there is a chance for duplication of data, in which column there is a chance for null values, okay? Then such columns are called as non-key columns because they contains duplicate values, they contains nulls also, okay? So such type of columns are not allowed to use as key columns, okay? They are just to hold the data, they are just to hold the data only, right? Now such non-key columns are partially dependent on the primary keys. Partial dependency is not recommended, they should fully depend on primary keys, okay? Why partial dependency comes? Simple point, when there is another primary key in the table, what happens? Instead of depending on the first primary key, you can use a second primary key also. That is the thing. See, when we have two heads, what happens? I may use first head or I may use second head. Optional is there. No, such type of options are not allowed. Only one. See, see, one important point for a house. See, we can compare this logic with a normal real-time, normal examples also, which we face in the real time. House is there. I want to put a security guard. Okay. Now there are two entry points. Then how many security guards are required? Two security guards. One for each entry point, one security guard is required. So it is a costly process for me. I need to pay salary for two security guards. I need to maintain two security guards always. Now, if for a house, if only one entry point is there, then one either in or out, everything through only one entry point. So how many security guards are required? Only one. That is the thing here. See, if I want to enter into the home, what is the way? Only one way. If I want to go out, only one way. That is called full dependency. Full dependency. Okay, there is no alternative for me. There is no alternative. I need to use only that specified way only. Only one way is there. Suppose if two points are there, if two doors are there, okay, two entry points are there for a house, what happens? If A and B, two are there, okay, I can use A or I can use B. So now tell me, are you dependent completely on A? Are you dependent completely on B? No. This is called partial dependency. Partial dependency leads to problems. Why? Either you can go in A or either you can use B. So then how can you say that, okay, always you performs the operation only in this way? There is no such assurance is not there. I may use A or I may use B. That is. So here, see this. Next class is there. 2:30. Right. So here, very simple point. If any if more than one key column is there, okay, simply remove that. For example, in one table, okay, just I will close this one by showing this example. This is the data, just assume, for a student. Student number is there, okay, name is there, father name, mother name, in such a way, address, so many details are there. Now, Aadhaar number, okay, and updated on and some other details. Right. Now here see student number. Say it is 101. Just assume. No two students are allowed to have same number, right? So that's why student number is a important key column. Okay. Key column means what? A column which does not allow nulls and which does not allow duplicates. Non-key column means a column which allows duplicates and which allows empties, I mean null values. Okay, that is. So 101, 102, 103, this is student number. It is a unique and not null. Whereas Aadhaar number, just assume. See, for two students can have same Aadhaar number? No. Say my Aadhaar number is something like this. Just right. Now the student number is one key column, right? Because the student number, okay, is unique and not null. Now the Aadhaar number is also one key column because it is also not null and unique. Now in this table, in this data, how many key columns are there? 2 key columns. So it means to get the student data, student number is mandatory. No, select star from student table. Okay, where the student number equal to 101. I can use select star from student table where Aadhaar number equal to 45896. So I can use either Aadhaar number or either I can use student number. So this is 2, right? So here 2 key columns. Now student name is a non-key column, right? So first, whenever you got the data, first you need to identify which is key column and which is non-key column. Next, non-key columns depended on which key column. You need to check. Remember that. This is the basic step. Okay, when you collected the domain data, I mean that properties are collected. Now among the properties, which property acts as a key column and which property acts as a non-key column. First, you need to identify. So, see this. See this. The name is dependent on. The name is dependent on which column? First check. Name is dependent on student number or not? Yes, it is dependent. But is it completely dependent? No. I can use to get the name. I can use Aadhaar number also. Right or wrong? Because Aadhaar number is also unique and not null. Right? As per my design point of view. So it means his name is completely dependent on the student number. Here, see this design. When we create a, see the 7th point. Non-key columns are partially dependent on the primary keys. Means in our design, name is a non-key column. It completely depends on the student number? No. It completely depends on the Aadhaar number? No. It is partial dependency. You should not design the table in such a way. Okay. See, the name is a non-key column. First name is a non-key column. Okay. See, mother name is a non-key column. Address is a non-key column. Right. You need to form a relation between the key and the non-key columns in a full dependency manner. You should not provide any alternative. Okay. Now remove this column, Aadhaar number, with its other details. Right. So Aadhaar number and the other details as one table, and student first name and last name and all are one. Whenever there is no Aadhaar number in this, then what happens? The address and mother name and first name and name should completely depend on student number only. There is no any alternative. Right, that is. Now here you may get a doubt. Suppose I want to know the other details of a student. Then how? See, these details are in other table. That is one design. Right. Sometimes the rules are also sometimes they leads to some problems. Okay. Here you should not use this as a key. Remember that. Suppose only Aadhaar number. Depending on this Aadhaar number, there is no any other details. Only Aadhaar number is there. Then keep this in the student table. Okay. If any other details, if any other columns are there which are related to the Aadhaar number, then make them keep them in a separate folder. That is the thing. So you need to identify. See here the important small shortcut for a database design. Identify the key columns and non-key columns, and identify how many key columns are dependent on one key column. So group them. That is one table. That's all. So I can't say it is 100% valid, but 80% is valid. Remember, by practice, you should be able to improve it. See, there are so many other options are there. First, you need to observe the domain data. That is important point. Is there any other columns dependent on the Aadhaar number or not? You need to check. Okay, that is. So identify that. Right. Okay. Time is over, right? Thank you. Thank you for all of you. So tomorrow, in the next session, we will continue the second normal form and all. Okay. See, even this point is also not yet completed, right? It is just off. It's completed. We will continue from the 7th point onwards. Okay. Once this normalizations are completed, again we will back to MySQL with full syntax. Then you are able to understand what is a perfect design, and there you get the list of total constraints and all there. Okay. Once this concept is completed, then you are able to know, okay, what is the importance of constraints, and you are able to create a concrete design. Without these concepts, okay, concrete design is not possible.